So the question here is to translate the following statement shown here on the right-hand side into logic. Someone did not read the proposal, and someone voted in favor of the proposal. So we're going to start out by contrasting it to the statement from the previous question. Someone who did not read the proposal voted in favor of it. Both are existential statements, but they're different in that in the statement on the left here, we're saying that there's a single individual who both did not read the proposal and voted in favor of it. By contrast, in the statement on the right here, we're saying that someone didn't read the proposal and someone voted in favor of it, and those two people can be different individuals. So there can be one person who didn't read the proposal and another person who voted in favor of it. They could be the same people or not, and that would satisfy the expression on the right. So we need a way to translate the difference into logic. So the logical expression on the left shows the solution to the previous problem. And note, there's exactly one quantifier because there's only one person that we're saying didn't read the proposal and voted in favor of it. So this quantifier is binding this occurrence of the variable as well as this occurrence of the variable. So that says there has to be one person to substitute for x that makes these true. So it would be the same person in each case. Now, on the other hand, in the expression on the right, we have two quantifiers. The first quantifier is quantifying the statement that someone did not read the proposal. The second quantifier is quantifying the statement, the other statement, that there's someone who voted in favor of the proposal. And because these are different quantifiers, they can be different people who satisfy each of the two statements. Now, remember that we apply the universal quantifier before applying this logical operator. So if you wanted to be very precise, you could put in the parentheses to make it clear, but they're technically not necessary because by the order in which the logical operations are applied, we apply this quantifier first, and then this quantifier, and then add them afterwards. Also, the fact that the variable name x here is used in both parts of the expression is completely arbitrary. We could have used different variable names. So for example, this expression here is logically equivalent to the expression shown here in red, in which we use y for the second part of the expression.